Welcome to the Fox One Corp series of SeeYou training videos. I'm Dave Springford. Please visit me online at www.foxonecorp.com. In today's video, I want to show you how we can open multiple windows in SeeYou so that we can see more information on the screen. We're also going to take a look at the statistics page, and in particular, the flight tab on the statistics page. As you can see right now, the screen is open in the layout that I prefer, where I have the route or the map screen one full window. On the right hand side, I have the legend, and on the bottom, I have the flight parameters. We can change the view or the windows that we're looking at by going to Window and Desktop, and we have some pre-selected desktops here. So for example, route and barogram would allow us to put up two windows that include the route window and obviously the barogram window. To get out of that, we can simply close one of the windows and then maximize our route window again. But what I want to show is how we can open whatever windows we want. So the first thing I'm going to do is I'll change the size of my route window here, just using the standard corner grips, and we'll drag the route over to fill about half the screen. And now what I want is I want to be able to fill the other half of the screen with statistics. So to do that, I'm going to hold the Shift key on the keyboard, and then I'm going to click on this statistics icon. By doing that, it opens a second window. So I'm going to drag this statistics window over here, and then just resize it to fill the whole window. So now we can see we have two windows on the screen, and we can work between either the windows. If we wanted, we could hold Shift again, and we could add, for example, the graph. And there's our graph window, and we can drag that window around, resize it, position it where we want, so we have the information that we want. So opening multiple windows is as easy as holding the Shift key and then clicking on one of these view options that we've discussed previously. Just going to make the map full screen for now, and we want to take a look at the flight that we have on the screen here and a little bit about the task options before we move into the statistics page. So the first thing that we can see is we have a nice triangle flight here, and on the corners we have round or cylinder turn point zones. This flight I actually flew with FAI sectors, so within SeeYou I want to change those to represent the sectors that I truly flew. So to do that, we're going to go Tools, Options, and then we're going to go back into observation zones. And as we've seen before in this scheme drop down, we can select from some pre-programmed schemes, or as we saw in a previous video, two that we made up specifically for the US contest rules. In this case, I want to use the FAI sector with start and finish line for this flight. So I'm going to say OK on this, and now we can see all that did was set the default. So any task that we set now is going to use those. So to change it for this particular flight, we're going to right click anywhere on the screen. We're going to go to Flight Properties, and then Observation Zone. And what I want to do is just move to the first turn point so we can see that cylinder zone. And if now I select default, we just set the default to be FAI sectors with start and finish line. If I select default, we can see that my FAI sector appears. And if we now go back to the start, we can see we have a start and a finish line here. So I'm just going to say OK. And with that, we can see on the map that our zones updated to sectors on the three corners. So now this flight, the statistics we'll look at will involve using those sectors. So to get back to our statistics window, remember we have multiple windows open here, so I can just use the Windows command to minimize that, and now we have the statistics window over on the right hand side. For now, I don't really need to see the map window to explain what we're going to look at, so I'm just going to maximize the statistics window so we can talk about it. So one thing that we want to look at is the sections, and each of the sections on this window are divided by the yellow lines. So general information, what does that show us? It shows us the date of the flight. It shows us whether the file has been verified or not. In this case, it says it's not been checked. I do not have the DLL files loaded into SeeYou to do automatic verification. And within the options up here, you can also set it to do automatic verification. Shows pilot name, glider type, all the glider information for the flight. Then it shows in this section our takeoff time with a sunrise, our soaring begin, that's where we released from tow, our soaring end, that's where we landed, and our landing time, which is also the same as our soaring end time, and a flight duration of 5 hours and 12 minutes. The next thing we want to take a look at is this declared task. If in your flight computer you put a task in, that task will show up in SeeYou here. If you flew without a task, then this section will be blank and it will say no task declared. And so what we can look at, the first thing is this a valid declaration? It says at the top, declaration is valid. That means the flight or the task was declared before takeoff. So we can see the date and the time of the declaration was 11:51 and the takeoff time was 11:54. If you make any changes to the task while in flight, that will invalidate the declaration. And if you're working on an FAI badge or a record, then you've invalidated your attempt. So the other things we can see here in the task declaration are all the things that are required, the point names, the latitude and the longitude. And then it also gives us some information about each of the legs. So the time required, duration for each leg, time we started each of the legs, duration, the speed achieved on each leg, what the wind was, and what the wind component was for that leg, which can be interesting. We can see, for example, on the first leg, we had a tailwind of 2 miles per hour, and then we had some headwinds on the next 2 legs. Down here, all turn points rounded okay, task completed. The next section shows us the flight statistics. And what this does is it breaks the flight into circling flight and straight flight. Before we get into that, the first line, maximum altitude gain. If you're an official observer, that's a nice line to look at if you're trying to assess whether somebody has made their silver or their gold or their diamond height gain. It's given to you right here in black and white, 3,186 feet gained. The altitude and the time of the low point, the altitude and the time of the high point. If you go up to Tools, Options, and set your height units to meters, then you can assess this directly against the 1,000 meters without having to do any of the conversion yourself. So top section here, circling, what it tells us is how much of the total flight time we spent circling. And we can see out of our 5 hours and 12 minutes, 49 minutes was spent circling, and that accounts for 16% of the flight. Over the flight, we have a 3-knot average vario. We gained almost 19,000 feet. And we also lost 4,000 feet while thermaling, or while attempting to thermal. And a total of 26 thermals for the flight. The same information is provided for all your turns to the left, all your turns to the right, and any mixed thermals where you turn both left and right in the same thermal. We can see 32% of the time turning left, 65% of the time turning right. The last line is tries less than 45 seconds. And what this tells us is the number of attempts really that we took one circle trying to locate a thermal as we were cruising. And we can see that was 2% of the flight, or 7 minutes. So without doing those, we could have saved about 7 minutes on this flight. The next section is the straight section. Total gives us a time of 4 hours and 19 minutes. That's 84% of the flight. Add that to the 16% circling, and we have our 100% total flight time. The distance done, this number includes all of the distance flown in circles, as well as all of your distance flown straight. So it includes deviations that were made as you zigzag down the course line, plus the circumference of all the circles that you flew. Shows us that we lost 17,000 feet while flying straight. We had an average netto of 1.4 while flying straight. So in this flight, we spent a lot of time in rising air. Tells us our average ground speed and average indicated speed. Total number of glides, 27. Should always be one more than the total number of thermals here. Average glide distance, how far between thermals on average? 14 miles. And the L over D that was achieved while cruising throughout the flight. Then it breaks it down into rising and sinking air. We can see that we spent an hour and a half of the flight flying through rising air, 2 hours 47 minutes through sinking air. See the speeds that were achieved. Flew slower, 72 miles per hour in the rising air, faster, 85 miles per hour in the sinking air. We achieved a negative L over D, so we actually climbed during the rising air time, and we lost altitude during the cruising time. And the lost altitude of 21 L over D. The other thing we can see is the height that was gained. So 50,000 feet was gained while flying straight ahead, and 67,000 feet was lost by flying straight ahead. Next section is the wind pictogram. And what this shows us is it shows us arrows to indicate the direction of the wind. So this one coming from the top down is almost northerly, and we can see a direction down here of 350. And this one coming from the south, pointing upwards, gives us a direction of 191. So speed and direction are given in the bottom line. The middle line, minutes, tells us the amount of minutes that were spent under each of those wind conditions, and the altitudes at which those wind conditions were present. Next section gives us information about our climb. So the vario. The red represents time in minutes, and the blue represents feet. We can see in here that a lot of time was spent less than 1.5 knots, and that makes sense because most of our time flying straight, we were at less than 1 knot. In terms of thermals, we want to look for the peak of the graph here, and we can see the peak is basically 3, 4, 5 knots is where we spent most of the time climbing, and that syncs well with our 3-knot average for the flight up at the top. We can see that we spent more time climbing at 3 knots than we did at 5, 6, 7, and 8 knots, for example. Next one is our altitude, and what that shows us is at what altitude range we spent most of the day. Much like the vario, the red is minutes, the blue is knots, so the climb rates at the various altitudes, and we can see that most of the time was spent between 40,000 feet. Finally, speed is the last graphic here, and the one change is we have green, and that shows us feet. So this is the height lost or gained at each of those speeds, as well as the time and the distance flown at the speeds. So we can see again, most of our time and distance was covered here between 80 and 110 miles per hour, and most of our height lost, which makes sense given the cruise speed, was at the high speed, and most of the height gained was at the low speed. I hope you've enjoyed this SeeYou training video. You learned something new about the statistics page today. If you have any questions, please post them in the comments below, and visit me online at www.fox1corp.com.